Good evening, ladies and gentlemen, and welcome to another edition of What's Happening. I'm George Binns, and here with my co-host, Elliot Margolis. And today we're doing a show about global warming, and our guest this evening is Kevin O Reilly. Welcome, Kevin.
Oh, thank you, George, and thank you, Elliot. And I appreciate the chance to share my thoughts on climate change today. Okay, so can I share the screen?
Yep.
Host disabled participant screen sharing.
Says it's disabled.
Yeah. While we're getting that set up, there's my screen. Okay. I have lived in Beverly for 42 years. I'm a proud resident, and I want to show you, I'm part of this group, these groups. I belong to several climate change groups. I'm an activist, and if you're interested, you should look into these groups. I don't represent them, though. So if I say foolish things, that's not their fault. So I became an activist, a climate activist, for a couple reasons, one of which is my family. This is our youngest granddaughter, Elena. And like everybody else, I'm concerned about my children and grandchildren and keeping them safe. And I do it because of patriotism. I see that climate change is a national security threat, and you can see here with the quadrennial review, the effects are threat multipliers, and 2019, changing climate are a national security issue. So I was a high school history teacher. I taught for 39 years, 35 of them at Hamilton Wenham, and loved it. I enjoyed being a teacher. I'm also, my area of interest is in critical thinking. And I've written 29 books, 19 on decision-making in history, and the other one's on critical thinking. So it's really a passion with me. And I want to apply that tonight to what we're going to talk about climate change. So critical thinking here, the way we're going to apply it here, because there's other things about critical thinking, has to do with evidence based on assertions. So I've made my cursor large so you can follow it. That you look for the reliability of sources, and that includes expertise, and I'll talk more about peer review later. That cause and effect is a clear connection between the cause and the effect. And in some ways, I think equally important to the other ones is confirmation bias. We all have to be conscious that when we take in information we agree with, we're not as critical. So for example, if I'm a opponent of capital punishment and I read something that capital punishment doesn't work, I look for what is in there that I can support. If I read something that says capital punishment is effective, which I don't agree with, then I'm going to be very critical. According to literature, what I'm going to be looking at is, must I agree with this? So then I'm going to be looking for, well, wait a minute, what kind of samples did they use? Did they, what were the sources they used? And I'm asking everybody to keep an open mind here, to look at the evidence and evaluate the evidence. And even if it's inconvenient for you to look at it and to change your mind if the evidence warrants it. So I'm going to be arguing, one more thing. We're focusing in this program just on what's the evidence show. So is there climate change? And I'm going to argue that there is climate change, that it's real, that it's partly caused by human activity, not totally, because there's other factors involved. And it's a serious issue and a threat to human beings and other creatures. So let's get started again, the focus is on, is the temperature of the Earth rising? That's the question. And is it rising substantially? So this quote is from the Intergovernmental Panel on Climate Change. And they say, these are the top experts in the world on climate. And they say warming of the climate system is unequivocal and unprecedented since the 1950s. So it's different than what's happened before. It's not a natural change. NASA, which is also made up of a lot of experts in the area of climate, that's how they get people there and back when they shoot them into space, says a 95% probability to be the result of human activity. And it's important to note that they say 95% probability. It's not 100% because we're talking about the future, but very high probability that it's caused by human activity. So this is some of the evidence. So we're looking into the evidence here. The report, again, Intergovernmental Panel on Climate Change, these are graphs. And if you look at the graph on the top, you can see that it's going up rapidly. And the bottom one is by decades. And again, the increase is more dramatic than it has been in the past. These are other studies. And what's really remarkable about this is how much they coincide. So these are different scientists. You can see NASA and Hadley and NOAA and all, that they seem to correspond with each other. They're reinforcing each other. And as you can see, the 2016 was the highest temperature. And if you had to guess, just take a second here, if you had to guess, what do you think 2020? Because this only goes up to 2019. Well, it turns out that it's equal to 2016. It's as hot as 2016. So if we take a look at the hottest years, take a look at that. All of them are, the top 5 are the 5 last years, and the top 10 are the last 10 years. And if we add in 2020, it's at the top. It's tied for first. These are not things that we want. Nobody wants to keep tying the record or breaking the record for the hottest year. So these are, again, a bunch of graphs. The point here is that the angle of the increase is so much greater than in the past. And again, they have varied by about 1 degree centigrade, and we've just gone up 1 degree centigrade in 100 years, not in 1800 years. So it's a huge increase. And people say, oh, it's only 1 degree. Only 1 degree? Are you kidding me? That's a big increase in a short period of time. This, again, these are other studies. This was done by paleoclimate scientists at Oregon State University, along with other ones. So these are averages. The black line is the average, and the red line is the one done by Marcotte. And this is a huge increase in a short period of time. This is over 12,000 years. So again, there's something unnatural about the temperature increase. Now, meanwhile, the CO2 in the atmosphere is going up dramatically also. So if we take a look at the right-hand side, it's, again, shooting up dramatically. The amount of CO2 in the atmosphere has not been higher for hundreds of thousands or millions of years. And that's a correlation. Correlation is when you have A goes up and B goes up. So we have to look and see to make sure that A, in this case, CO2, causes more heat on the Earth, a warming of the planet. Not that the warming of the planet causes CO2 or something else causes both of those independently. So we're trying to establish cause and effect. We only have correlation. There are other correlations, however. When they looked at before I get to this slide, when they looked at ice core samples, they correspond to warm periods and cold periods. When there's warm periods, the ice core samples show there's more CO2. And when they're colder, there's less CO2. And one researcher said, when CO2 levels jumped rapidly, the global warming that resulted was highly disruptive and sometimes caused mass extinctions. That's kind of worrisome. And those were increases over thousands of years, not over 100 years. Humans today are emitting prodigious quantities of CO2 at a faster than ever, even the most destructive climate changes in Earth's past. So this is something that we have to consider. Okay, so that strengthens the correlation. When A goes up, and when it went up in the past, it was also because there was this other thing. So how is it that greenhouse gases trap heat? Well, if you follow on the left-hand side, solar radiation that have shorter wavelengths, so they're not blocked by greenhouse gases. When they come back out, they're thermal radiation, which have longer wavelengths, and some of them, not all of them, some of them are reflected back, some of them are reflected out in the atmosphere, and that means that there's going to be more heat coming back to the Earth. And again, it's only a few percent, but boy, that can make a difference. If it is the case that there's greenhouse gases, so if you look along this blue line, greenhouse gases here, what we should see is over here, outside that blue band, is colder, and that is what we see. So the stratosphere here, the heat coming in, when it goes out, a little less goes out. Some of it's trapped here. This should be colder because it's not coming out equal to what came in. And if you look at this graph up here, the stratosphere since 1980 has been getting colder. That provides more evidence that these greenhouse gases are causing the problem. There's let's see, I don't know if this is in the way. Satellite measurements show that an extra 0.6 watts per meter squared going in versus coming out. So there's extra going in versus coming out. And again, I want to emphasize, these are careful monitoring. They're gathering data all the time. So we also know that greenhouse gases absorb heat radiation because they did experiments 170 years ago just to show that they absorb heat. So we've known that they've done this, that this has this effect for decades and decades, over a century. So what do we have? When we look at this, we have the claim is the Earth's temperature is increasing significantly due partly to greenhouse gas emissions. So we go back to the evidence, careful evidence collection. Models are compared to observations. I want to talk about that for a second. They do a model, let's say in 1980, and they apply the model to 1980, and they see what it says it's going to, what should happen to the temperature. And then for 2000, so 20 years later, and then they look at 20 years later and they see how close they came to what actually happened. And they've been doing this for decades. And the models are getting more and more accurate, partly because they have more and more monitors around the globe and both satellites. So the models are getting better compared to when they compare them to observation. So in that sense, we'll give it 2 thumbs up. The evidence is really very strong. Secondly, as I said, the leading scientists in peer-reviewed sources agree on this claim. So I wanted to talk about peer review. I experienced peer review in the history field. So in order to get published in a history journal, you have to get it through peer reviewers, historians, and they look at your footnotes, they look at claims you made, wait, you didn't support this. So it's harder to get things published in history journals than it is to publish it online. Like, I could just put it online and that's my opinion, and there you go. So these go through a process. It doesn't make them right necessarily. It makes them more reliable because they had to go through that step. These articles were in peer-reviewed journals. So they were reviewed by other people, and in some cases they said, wait a minute, your evidence is not good. Or people tried to replicate experiments and they couldn't, and then they got in arguments. That's what scientists do. So in that sense, 2 thumbs up. The evidence is very reliable. The sources are reliable. And then, as we saw, the connection between the cause and effect was demonstrated. They showed how A led to B, not B led to A or C led to both of them. In that sense, 2 thumbs up. So now we're going to move to objections. So there's 7 of them here. These are not the only ones, but these are the ones I've heard most frequently. And if there are other objections, we can talk about those later. So the first one here is it's natural compared to geological time. So let's look into that one, and then we'll go down the list and look at the various objections. So this is a graph showing the changes in temperature. And again, I want to emphasize it's degrees, single degrees here. So about 3 degrees colder than now, but that's 20,000 years ago. So the slope of this change is pretty slow. It goes up quite a bit here, and then it's some cooling, and we're going to talk about that, and then just dramatic increase. So when people say, well, it's, in I mean, there's been colder and warmer periods in the past. Yes, not this fast. So 1% increase was in 100 years. And again, that's why this line slopes so fast, because when you get in geologic time, like, we've never seen anything like this. And the next 100 years could be another 2 to 3 degrees. So one of the things climate activists want to do is keep the increase below 2 degrees centigrade. That's unheard of. 2 degrees in only 80 years? It's never increased like that before. So you have 2 increases, what's happened the previous 100 years and the next 80 years, that are out of proportion to anything seen before. Okay, so based on this, the argument is it's natural and small compared to geologic time. We saw that the evidence for that doesn't add up. The large temperature increases are in the past decades. So in that sense, they get a thumbs down. It's not really the evidence doesn't accord with their argument. The leading experts agree the temperature increases are large over a short period of time. Most, I don't know if there are any in peer-reviewed journals that make this argument. And so thumbs down on that one. The second one is we're coming out of a little ice age. So of course, we're warming up. So here we have a graph that might illustrate the point. So these are if you follow the line, it's been getting colder, and this blue area is the little ice age. And you can see the temperature in the ice age, so this is from 1400 to 18 something, is a 0.2 centigrade. And yet we had this little ice age. So a very small change can make dramatic effects. So that one is a cooling by 0.2 degrees centigrade. But then if you look at the green line, it's warming by, I don't know if you can see it, I don't know if that's in the way, 0.8 degrees centigrade in very short period of time. Again, over and over, the effects don't look like, they look very dramatic when you look at this. Okay, so now this is a different graph, this by a professor in Australia, and he plotted the various natural changes. So without any humans, this is what he's seen. The sun activity, El Nino, La Nina, these various ocean currents, volcanoes, very important. Volcanoes are very important. So it goes up and down. The red line is a model of human plus the natural factor. So it takes the blue and adds the humans in. And the question is, so those are two models, which one accords to the actual increase in temperature, so observation. And sure enough, the observation accords with this. It actually goes along with the natural ones up until about 1915, not exactly, but somewhat. So it's possible to say that the coming out of the Little Ice Age might have had some effect up until World War I, and then it completely loses it and goes along with CO2 emissions or greenhouse gas emissions. So how does this one stack up? Well, it's okay for the Little Ice Age, but it's weak after 1915. So, okay, it's not terrible. The original article by this scientist, Okusafu, was refuted in a following issue in the same journal. And they had pretty negative things to say about the evidence and all that he had in there. So it was peer reviewed, but it was peer reviewed negatively. So he didn't get much love after he published this article. And if you want to, I can read you some of the quotes of his very scathing article. And the rising temperatures since 1915 are, according to the evidence, due to greenhouse gases, which breaks the connection between the Ice Age, Little Ice Age, and the increasing temperatures. So that one gets a thumbs down also. Okay, the third one is a new ice age is coming, so global warming is actually a good thing. So this one is due, so if you trace back where this started, it started with an article in UPI after a conference by in which this scientist, Valentin Zarkova, wrote a paper, and they did a press release, and UPI picked it up and said, "Oh, it's there's a coming ice age," and then that was picked up. So this is in 2011, and that was picked up online, and it just went wild. There was lots of people saying this. What she actually said, so if you follow the cursor, what she actually said is there'd be a 60% drop in sunspot activity. She never said solar radiation in general. She's not a climate scientist, and she never said anything about climate on Earth. She just was talking about solar, basically sunspots. You see here that there's a correction in the UPI article. So later on, they put a correction out and said, earlier version of this article inaccurately stated that scientists have predicted bitterly cold winters. In fact, the research focused on solar activity and did not make any prediction about possible future climate effects. But the horse had left the barn and people kept talking about this. The second one is down here, and this one is from NASA, and this guy said it was seeing a cooling trend, except what he said is high above the Earth's surface near the edge of space, they're losing energy. People misquoted him and said the Earth is cooling according to NASA. And it wasn't that. In fact, it provides evidence that the Earth is warming, as we showed before. If there is this band of greenhouse gases, it should be colder in the upper atmosphere. So it really wasn't. That's how this got started, according to what I understand. Well, the other problem with this, because there's multiple problems with it, is it's not coming soon. So according to these researchers at the University of Calgary, presently experiencing an abnormally long interglacial called the Holocene, It's lasted 11,000 years. New glaciation has been expected to begin. However, due to human-induced climate change, the next glaciation is being delayed anywhere from a few thousand to hundreds of thousands of years. Meanwhile, on the other side, if I can move this, oh, nuts. Oh, I see. So this one says that there could be a buildup of ice sheets in the next several thousand years, but the interglacial period could probably last 50,000 years. And with accumulation of greenhouse gases, it's more like 100,000 years. So let's come back to what people are arguing. Some people are saying the new ice age is coming, so we'll have, a little bit of global warming will be good. What they're saying is, in the next 100 years, people are going to die. People are going to get into wars. There's going to be these problems, but that's okay, because in 10,000 years, we're going to put off. You got to keep in mind the scale, the pace of glacial time, geologic time versus human time, which is, in this case, very quick. So it's not based on strong evidence. In fact, it's a misunderstanding of the evidence. So 2 thumbs down for that. And it's not based on reliable sources. Again, I don't know all the peer-reviewed articles, but don't believe any peer-reviewed articles are saying, oh, we're coming out of a ice age, and therefore our new ice age is coming, and therefore, we don't need to do anything. So 2 thumbs down on that one. Okay, 4th one is that greenhouse gases are a small part of the atmosphere. Well, that's kind of an interesting one because it's the fallacy of that large effects. So if we look here, fallacy of large effects must have large causes. So think about this. Would you agree that there's only a small amount of arsenic in your drink, so go ahead and drink it? Or he couldn't be drunk, the alcohol level in his body is only 0.0% of his body weight. Or there's only a trace of poop in your ham sandwich, so go ahead and eat it. Trace elements actually can make a big difference. So this one doesn't seem to hold water. There's agreement that greenhouse gases are a small part of the atmosphere. So, okay, we agree on that. The source making this argument, the sources are not peer-reviewed, so they're unreliable. So that's thumbs down. And it's based on the fallacy that large effects must have large causes. So, okay, the next one is...
At this point of the game, we're already through our about half an hour. So I think this is a good point to hold up for a second and think about what happens next. And I think you've got more data and more information you want to present. And I think we ought to do another show and continue the discussion starting from number 5. It's a good place to be. So,
okay,
ladies and gentlemen, thank you for joining us this evening. And this is a really big subject that needs to be discussed further. And we're going to have Kevin back to do another show. We also did a show, if you remember, a while back with the contrary opinion, and that's with Frank Bellini, and he's agreed to do a second show of his. And once we're finished with that, we're planning on having a get-together with Frank and Kevin and have them discuss what's good and what's bad about their presentations. Once again, ladies and gentlemen, thank you for joining us, and we'll see you next time.